Good morning, everyone. This is Mrs. Bokerman. I am going to teach you a little bit about polar complex numbers. So, one of the things that many of you have asked me is what is polar good for? And we've spent a lot of time graphing things that aren't functions and very cool things like roses and lemniscates. But polar is actually also really useful for the complex number system. So, let's kind of review what a complex number is. That means it has an I in it, imaginary. And so it's generally written as a plus bi in some form of imaginary. So these are two numbers, and I believe that you did a lot with them last year in Algebra 2. But anyway, you could take two complex numbers and you can multiply them, and you can take two complex numbers and you can divide them. And so I kind of already worked it out for you just to save some time, but that's a lot of algebra that you have to do. And then you have to get into like, hey, remember when it was I squared? That's really a -1. So that this piece over here really became a positive. And then you will see that I grouped my non-i's together with my i's together. And I could do the same thing with dividing, but you kind of have to rationalize because it's that rule that you can't have imaginary numbers in the bottom. So this is old. You are not expected to know how to do this, but we did want to show you how you could get by without doing this by using polars. So really quickly, I want to review part of the polars. So you can have a rectangular point and you know that that's xy, and you can have a polar point that's r theta. So different than these two is you could have a complex number. And so to indicate a complex number, we write it as x plus yi, or sometimes you'll see like a plus bi. It doesn't matter. It's just a constant. So I can convert something that's in rectangular to something that's in called polar complex. So if it says the word complex, we want it in rectangular. If it says the word polar complex, we want it in polar form. And so it uses a version of r and theta, but looks very similar to this in that it is z equals r times the cosine of theta plus I sine. So there's still a regular and imaginary component to it, but you'll notice you have an r and theta. So the first thing I'm going to show you is literally how easy it is to convert between the two. So here is something in rectangular that we're going to convert to polar. So what I want you to understand is if you're converting to polar, like always, you need to know r and you need to know theta. So the first thing I'm going to do is I'm going to find r by doing a squared plus b squared. Now notice I'm not using the I when I'm doing the squaring. I'm just using the coefficient in front of it. The I is just indicating it's the y value. Okay, it's not actually part of the number. So I took the square root of 3 plus -1, got 4, which is 2. So my radius is 2. Then to find theta, again, I do inverse tangent, and I'm doing -1 over root 3, and I want to put that angle in quadrant 4. How do I know it's in quadrant 4? Because x is positive and y is negative. And so if I do that, that would be 11 pi over 6. Now, this is a one time where in polar, you are restricted in your angles, and your angles have to be 0 to 2 pi. So I cannot use negative pi over 6. So the correct answer is, ta-da, z equals, here's where I put r, and here's where I put theta. And I leave it like this, okay? If you were to actually start simplifying, you would just go back to where you started. So this is r, and that is theta, okay? So similarly, I could go the other way, and it's actually way easier to go from polar to rectangular. So now in polar, let's say I start with something like this. Well, all I have to do is figure out what is the cosine of 30 degrees and what is the sine of 30 degrees. Cosine of 30 is root 3 over 2, sine is a half, and then I distribute the 2, and boom, here it is in rectangular. Because the 2's will cancel, so I'll just have root 3, and the i's will cancel, I'll just have 1. So one of the easy things is we might just ask you to write something from rectangular to polar. Okay, but then why is that useful? Well, because now instead of doing all this algebra on the warm-up, instead of doing all this algebra, we can really quickly multiply two things and divide two things. So here are two things that you will need to know. If I want to multiply two numbers and they are in polar, all I have to do is multiply their r's and add their angles. and make sure that after I add my angles that it is within 0 to 2 pi. So if I had two complex numbers, I could boom multiply them and not have to double distribute and do all that algebra. It would be done. Similarly, if I had two answers that were in polar and I wanted to divide, I would just divide my radiuses and subtract my angles. And subtraction is where you have to be careful because you have to make sure it's between 0 and 2 pi. So you can pause this video and write those down if you need to, and then I'll show you what I mean. All right, so if you wanted to multiply these two numbers, notice they are written in polar form. So when they're in polar form, it's very fast to do this. All I have to do is take 3 times 5, that's 15, and add 30 plus 90, and I get 120, and boom, I'm done. Now, this is in polar complex. If I wanted to write it in just complex form, like the second part, all I would have to do is note what is the cosine of 120, what is the sine of 120, and multiply by 15, and I'd be done. Similarly, if I want to divide, I would divide my R1, so 3 divided by 5, and then subtract 30 minus 90 is negative 60. Now, the only problem, like I mentioned above, is I cannot leave this as negative 60. I have to convert it. So if I go all the way around the unit circle or add 360, I would be at 300. So I can leave it like this. And again, both of these answers are in polar complex form. It's not that bad to put them into rectangular by just actually figuring out what those are and distributing. Okay. So you could also try the last example on there, but that's really all you need to know about the basics of polar. We will only ask you to multiply, or we will only ask you to divide them. There's other things that we're going to do with them that you can find in the next video. So lastly, if you can do it with degrees, you can do it with radians. Very similarly, I would add them. So a pi thirds plus 4 pi thirds would be 5 pi thirds, and 5 times 10 would be 50. And I'm done. I don't have to do anything else. And then if I were to divide them, I do have to make sure that it's in between 0 and 2 pi. So I did 5 over 10 and negative 3 pi over 3. But then that reduces to negative pi, which if you put it on the unit circle would be regular pi. So hopefully that makes sense. Don't overthink this lesson. It's very simple. Can you multiply them and can you divide them? You'll see in the next video what else we're going to do with polar complex. See you later.